All right, on tonight's episode of Python Papi, we're back inside our artificial intelligence course, and we're still doing our natural language module. Let's have a look at what we went over tonight. Now, last night, the last topic we touched on was the distributive representation, and we're going to move on from that tonight and pick up where we left off. But how are we going to come up with these values here, that make up our distributive representation that spread across multiple values? Where do these values come from? How can we define the meaning of a word in this distributed sequence of numbers? Now, to do that, we're going to draw inspiration from a quote from British linguist J.R. Firth, who said, "You shall know a word by the company it keeps." In other words, we're going to define the meaning of a word based on the words that appear around it, the context words around it. Take, for example, this context: for blank he ate. As you can see here, we have this sentence: for blank he ate. You might wonder what words could reasonably fill in that blank. Well, it might be words like breakfast or lunch or dinner. All of those reasonable, all of those reasonably fill in that blank. So what are we going to say? So what we're going to say is because the words breakfast, lunch, and dinner appear in a similar context, they must have a similar meaning. And that's something a computer can understand and try to learn. A computer could look at a big corpus of text, look at what words tend to appear in similar contexts of each other, and use that to identify which words have a similar meaning and should therefore appear closer to each other inside of a vector space. And so, one common model for doing this is known as the word to vec model. Word to vec is a model for generating word vectors. It's a model for generating word vectors, a vector representation for every word by looking at data and looking at the context in which a word appears. You can see here, I don't know why that just moved. Sorry about that. You can see here, this is a representation of a word vector. We have a bunch of words at a bunch of random locations inside of a vector. The idea is going to be this. If we start out with all of the words just in some random positional space and try it on some training data, the word to vec model will do what the word to vec model will do is start to learn what words appear in similar contexts and will move these vectors around in such a way that hopefully the words with similar meanings, breakfast, lunch, and dinner, and book, memoir, and novel, will hopefully appear to be in near each other as vectors as well. So you can see a representation of that here. You can see how the words that are alike gravitated towards each other. We have breakfast, lunch, and dinner. Then on this side here we have memoir, book, and novel. So one other interesting side effect of word to vec is that it's also able to capture something about the relationship between words as well. Let's take it. Let's take a look at an example of king and man. Here, for instance, are two words, man and king, and these are each represented by word to vec. These are each represented by word to vec as vectors. So what might happen if we subtracted? Why is this thing moving like that? Sorry about that. So what might happen if we subtracted one from the other? Okay, we calculated the value king minus man. So you see here we have man, we have king, and we have king minus man. And I keep pausing because there's a bad glare, so I'm trying to position the laptop just right so I can see the actual words on the screen. But that will be the vector that will take us from man to king. Somehow represent this relationship between the vector representation for the word man and the vector representation for the word king. And that's what the value king minus man represents. Now what would happen if we took the vector representation of the word woman and added that same value king minus man to it? What we would get what we would get as the closest word for that, for example. So here we added the word woman, we replaced the word man, we added woman, but we kept the same king minus man representation. And we're trying to figure out what word would we get in relation to this. So instead of getting king up here, because we have woman now and we have king minus man, we should generate a new word in theory. Now, we've somehow been able to capture the relationship between king and man, and we apply it to the word woman, and we get a result, the word queen. So word to vec has been able to capture not just the words and how they're similar to each other, but also something about relationship words and how those words are connected to each other. And I'm going to stop it right there because we did do a lot more note taking. This isn't everything I just read wasn't from tonight anyway. This was from a few nights ago. I was just backed up on reading exactly what we were going over at the time with you guys. So yeah, We went over a lot of more interesting concepts tonight. We didn't do any new coding or writing any new code, but yeah, it is what it is. Light note taking, so I'm gonna take it as it comes. But of course, I will keep you guys posted every step of the way. For now, this is the Python Poppy. You guys stay Gucci.